Hi everyone, welcome to mathematics class with Zara. Today our topic is indices. Indices is the plural form of index. What is an index? An index is a number that tells us how many times a term has been multiplied by itself. Given this expression, which is read as a raised to the power of x. This hex is telling us how many times a has been multiplied by itself. In this case, indices or index are usually positive or negative numbers. So if you have this, a is usually with the base, is known as the base, while hex is the index that we are talking about. The index, or we can call it power, that is how many times this a is multiplying itself. If you have a raised to the power of 2, this is telling us that a is going to be multiplied by itself twice, that is a times a. That is indices. If you now have another form like this, n a raised to power x. In this form, this n is known as what? Coefficient. N is known as coefficient of this expression. So this term, it is the a that is having the power of x, not n. So a here is still the base, while x here is the power or index. Laws of indices. There are rules for solving indices. The first one is the multiplication law. Multiplication law. The law states that if you have two expressions with the same base multiplying each other, you add up their powers. That is what the law states. Usually, before you can apply the laws of indices, their bases must be the same before you can apply any of the laws. So multiplication law states that you add up their powers. For example, you are given a raised to the power of 3 multiplying a raised to the power of 4. In this case, the law states that you add up their power. Give you a raised to the power 3 plus 4, which is a raised to the power of 7. So now we are going to be proving why this is this. We are going to be proving why a raised to the power 3 multiplied by a raised to the power 4 is giving us a raised to the power 7. A raised to the power 3 multiplying a raised to the power 4. In this case, we discover that a raised to the power 3, like we explained earlier, index power means how many times it is multiplying itself. A raised to the power of 3 is telling us that a is multiplying itself in 3 places. A times a times a. That is a raised to the power of 3. Now, a raised to the power of 4 is telling us a times a times a times a in 4 places. Now, we are multiplying the two. That is, we are multiplying a3 by a4. So, we are having a times a times a. This is the first one, multiplied by a times a times a times a. Now, if you want to solve this, it becomes a in how many places? 1, 2, 3, 4, 5, 6, 7. So a in 7 places. If you recollect earlier, using the law, we have it as a 3 plus 4 equals to a raised to the power of 7. Now we have proven this to give us this. So that is multiplication law. The second law is the division law. Division law states that if you are given two terms with the same basis dividing themselves, we have to subtract their power. That is a raised to the power of x minus y. In this case, for example, we have a raised to the power of 5 dividing a raised to the power of 3. Remember, the base could be anything. In as much as both are the same, the law is applicable to it. So it doesn't matter whether it is a or x or 2, it could be numbers, it could be alphabets, but they must be the same. In this case, you discover that from the law, applying the law directly is a raised to the power of 5 minus 3, which is a raised to the power of 2. So now let's prove this. A raised to the power of 5 divided by a raised to the power of 3. We all know that a raised to the power of 5 is a in 5 places, 3, 4, 5. Dividing a to the power of 3, a in 3 places. So now a cancel a cancel a cancel a. We are left with a by a over 1. So a times a means a in 2 places. So over 1 is going to have a squared. So we have proven that this is this. Let's solve this exercise applying laws of multiplication and the division as well. In this case, we are having the multiplication. Now, I've said earlier, we have 4 is the coefficient here, 7 is the coefficient of the indices here. So, cases like this, you first of all calculate or solve out the coefficient separately, while the indices are solved based on the laws. In this case, we are going to be multiplying 4 as the coefficient here by 7, the coefficient here. Then the indices itself, a is raised to the power of 3 here, while a is raised to the power of 2 here. Both are having the same basis. So we have it as a raised to the power of 3 times a raised to the power of 2. Here we apply the law. Here we calculate it out normally. 4 times 7 is 28. And a raised to the power of 3 multiplied by a raised to the power of 2. Remember, multiplication means addition. So we are adding 4 by 7, 28. A raised to the power of 3 by a raised to the power of 2 is a raised to the power of 3 plus 2. So this becomes what? 28 a raised to the power of 5. That is that. We are going to be solving a more complex example, which is this. Here we have two different bases, x and y. There are two different bases, where 4 is the coefficient here, 3 is the coefficient here. So we are going to expand this and write it out as 4 multiplying x raised to the power of minus 3 multiplied by y raised to the power of 5, or multiplied by 3 multiplied by x raised to the power of minus 2 multiplied by y raised to the power of minus 3. This expression is the same as what is here, just that we included the multiplication sign. In this example, what you do to make it easier is to collect the like terms. We all know that 4 will be multiplying 3, then the x which is raised to the power minus 3, collect the like terms. We have another x here raised to the power of minus 2, then multiplied by y raised to the power of 5 multiplied by y raised to the power of minus 3. Here we've collected like terms. 4 times 3 is 12 multiplied by x raised to the power of minus 3 times x raised to the power of minus 2 times y raised to the power of 5 times y raised to the power of minus 3. Here we can apply the multiplication law that states that when there is multiplication with the same basis, you add up their power. Here it becomes 12 multiplied by x raised to the power minus 3 plus minus 2 times y raised to the power 5 plus minus 3. In this case, we now have 12 multiplied by x raised to the power minus 3 plus times minus is minus 2 times y raised to the power 5 plus times minus is what? Plus times minus is minus 3. Here we now have it as 12 x minus 3 minus 2 is minus 5 multiplied by y 5 minus 3 is 2 to give us what? 12x minus 5 y squared. So that is the solution to this expression. We are going to be simplifying this using the division law. In this case, you divide the coefficients. 21 is the coefficient here divided by 7, the coefficient here. Then a raised to the power of 9 will be dividing a raised to the power of 2 because both are having the same basis. 21 divided by 7 is 3. Then we have a. Remember, the division law states that what you subtract the index or power. So a is the base, 9 minus 2. Because of this division, we have a minus here to give us 3a raised to the power of 7. Looking at this, just like the previous multiplication, we are having two bases. 24 is the coefficient here, 4 is the coefficient here. C is the base, having 6 as the index. D is the base, having 3 as the index. Likewise here, C is the base, having 2. D is the base, having 2. The coefficient here is dividing these coefficients. C6 is dividing C2. D3 is dividing D2. So all multiplying out to give us 6. C raised to the power 6. Division states what? Minus. So we are subtracting now. Then D3 subtract 2. So that is what this is giving us. So we have 6 C raised to the power 6 minus 2 to give us 4. Then D 3 minus 2 to give us 1, which is what? 6C raised to the power 4D.